Hi, I'm Frank Reichstein. I am the lead software architect for Aruba-OS-CX as it's applied to the 8400 product line. So the Aruba-OS-CX is something relatively new, obviously. This just getting started in the last few years and trying to do something a little bit differently. Now this will be the only marketing-esque slide that I will show you today, but just to get us rolling with where we're headed, show a little bit of what we're about and what we're trying to achieve overall in this solution space. So something we've talked a lot about and something you'll continue to hear a lot more about as time goes on is the programmability, right? The entire focus here is make sure that from the get-go we have something that is programmable and can be used in any software-defined application that you might want and be able to extend and make networks more usable and add additional customer value for our customers in the field. Security is absolutely a huge concern. We talked a little bit in the hardware presentation about the fact that we're using multiple TPMs in order to ensure that we can validate the authenticity of the hardware and of the software that's running on the device, providing that we have a secure root of trust verifying the software from the point that it's first loaded in the BIOS all the way through to the actual product code up and running, and then validating any new product code that you would want to run on the device. Extensible. So we're built with a REST API and built with a lot of the modern technology and solutions such that this is an easily extensible solution to be able to be deployed with ease and to be able to add new functionality on the go to get you up and running and advance your network. Innovative. So I think, one of the most important things is that we're really doing something interesting here with network analytics. And the ability of that network analytics engine is based on the foundation that we created in Aruba-OS-CX. So with that, let's jump in a little bit to what is Aruba-OS-CX and what's our philosophy behind it. So we're not starting from scratch here, right? We have a long history in the networking industry, 20 plus years of protocol and protocol stack implementations that have been written, refined, improved, and gotten to the point where you had a very solid base and a rich protocol stack. This goes all the way back. I was started as an engineer within this organization. I actually developed the original spanning tree protocol that we had in the box nearly 20 years ago. That same protocol stack is what we used when we did spanning tree in Aruba-OS-CX. We just had to form it to fit the new modern design of a network operating system that we intended and the philosophical guidelines that we'd created for this operating system. So what does that mean? What's our philosophy? What are we about? So the main thing that we're trying to accomplish is driving towards being database driven. We want to make sure that everything is expressed in the database so that we know and can control and can make things accessible to the end user. Leverage Linux. We don't want to do everything from scratch and have to be owning and recreating the wheel. Where possible, we want to make sure that we can take advantage of the community. And that means we base ourselves on Linux and we stick as close to that open source community as possible. Contribute back to the open source community where we need something new and try not to modify Linux as it is, right? We want to make sure that as things go forward and advance in the community, we can stay on top of it and continue to advance the state of the art, as it will, to move our products forward and to add additional customer value for our customers. Fully programmable. This will be the theme you'll hear over and over again as we go through. There's nothing that is not exposed through a programmable interface to interface with this device and with devices that will be based on Aruba-OS-CX as we go forward.
Nothing that's not exposed, so that means the API is there, fully documented and supported, and customers can use it if they want?
Absolutely. And later on we'll go into a demo. I'll actually show the documentation interface and we'll walk through a couple of simple scenarios using that interface to actually program things through the REST API as opposed to having to do it through the CLI.
And the previous slide mentioned Python. So does that mean
Correct.
There's custom libraries that have been released to support this OS? Or?
There will be a conversation later on. The Network Analytics Engine will talk explicitly about Python and how we're using Python and making Python available for teams to interface and grow the capabilities. And in addition, we're actually interfacing with existing Aruba communities so that other people can develop and share Python scripts that will enhance the capabilities. But we'll go into much more detail on that in the second, or the presentation after mine.
Okay, cool. So I'll leave those questions till then.
Resilient. So we want to make sure that what we're doing here is absolutely resilient and robust. You want multiple layers of redundancy within your network, right? You don't want any single device to be a choke point. You don't want any single protocol to be a choke point. So absolutely every software component must be resilient. And then supportable, right? So you don't plan for things to go wrong, but you know that in the modern era, there's stuff that's going to happen. So when it does, you must be able to respond, capture information, and make sure that you can get to the bottom and root cause issues, and make sure that your customers continue to have a network that is reliable and moving forward.
So to the 2 points there about the database-driven leveraging Linux, because the question came in is, what flavor of Linux and what database are you leveraging for that?
So we're two questions. First off, what flavor of Linux? So we are not using a Red Hat or an Ubuntu. We're using a roll your own, using Yocto as our build infrastructure to create a packaged Linux distribution. The database that we're using is an in-memory database. It started from open source projects. We've contributed back to open source products, but we've substantially improved that database above and beyond what was available within the community.
So Redis or?
Not Redis. So we started from OVSDB, Open vSwitch database. So we started from that. We've upstreamed somewhere on the order of 25 commits into the OVS community. But as our needs and their needs differed, we took our own version and enhanced it to support the physical switch instance that we're creating, as well as a chassis environment, which really wasn't something that they were envisioning.
So effectively now it's a forked version of OVS.
OVSDB, correct. Yeah, but still using the same schema specification languages, although we have put some enhancements on top to support the richness of the feature set that we're providing. Okay, good questions. Thank you very much. So this is the framework slide that we'll use as we go through the rest of the presentation to kind of get a sense of where we're at and what we're talking about. So I won't go into a lot of detail on this slide right now, other than to flash it up and just get a quick perception of what we're talking about, right? Critical point, current state database on the top. That's the thing that we're going to drive, and that's the thing that enables the rest of the solution and concepts that we talk about. The other thing I'll note on this slide, because it doesn't necessarily come through much anywhere else, the arrows are north-south. They're not east-west. Typical network operating systems of the past, almost all the arrows are east-west. You have a highly matrixed solution as opposed to something that is a very strict, well-defined architecture that ensures communication is happening in one direction. So taking that to the next step, let's talk specifically about our in-memory current state database. So this is our fundamental philosophical design choice. Everything is expressed into the database as a desired state, right? So we're not allowing any given daemon to talk to any given other daemon and creating all these matrix paths that create for large failure domains, right? Everything is in this database, be it the configuration of a protocol, be it the current status of any given feature, statistics about your port counts, your ACL hit counts, whatever it is, it's expressed within that database. And this also includes internal state, which allows us for some strong resiliency features. If any given daemon needs to fail or crashes, it comes right back up, reads its state back from the database, continues on as if nothing ever happened in the environment. Again, reiterate the point, agents do not interact with each other outside of the database. They are expressing their desired state and their intention into the database, and other daemons will react to that. So some of the benefits that we are after here, so high modularity, every daemon, because it can't talk to anything else and isn't matrixed in with everyone else, it's highly modular, it's highly contained. If we need to add or update any given module, we can do that as a point operation and not necessarily impact every other daemon throughout the system. Full visibility. Because,
Okay,
go
so
ahead.
quick question to the
Sure.
practical application of that. So say it's an OSPF daemon, OSPF falls over. Now, a state is still in that database. Do I have an impact to the forwarding?
There wouldn't be any impact into the forwarding. You would have to go back through a graceful restart to get back into sync with the rest of the database in the case of OSPF.
But I've still got a fully loaded forwarding table during that
Correct.
time, and so I'm only impacted for the time, well, in theory I'm not impacted at all, but for whatever changes might happen to that forwarding database,
Yes.
in the OSPF process, I might be nominally impacted until OSPF restarts, reloads, syncs back up and goes again, which should be sub-second?
The restart and getting back up and running is sub-second. The amount of time it takes to do graceful restart extensions with the neighbors will be some period of time longer than that, but the actual restart is definitely sub-second.
So how does that, so if it's signaling a graceful restart to the neighbors, so how is that handled if the OSPF daemon itself is restarting? Is there another function that signals the graceful restart?
Actually, the daemon itself will acknowledge the fact that it was down and send the graceful restart out, right? So
Gotcha.
you're
Okay.
still within,
So
you're
during
sub-second,
the
you're
reboot
well
of the
within your
daemon
window.
process, that's one thing that happens.
Correct.
Gotcha. Okay.
So what we're covering here, folks, is a really, really important point. If you go back a decade in our industry, there was a lot of talk about process restart and process separation as we move through kind of different network operating systems design. This is based off of kind of distributed systems cloud programming fundamentals. So as Frank said, everything is in that database, which means that process restart or switchover is just an artifact of the architecture. It's actually not net new code, because on a switchover, for example, that's almost the same as that same daemon crashing and restarting or coming at a boot the first time. It's just I attach the database, I'm told what my state is, it's my job to get into it. I'm not allowed to hold private information, if you will, that would complicate my logic and how I either boot or recover after a failure. So it's the high availability and resiliency is an outcome of the architecture. It's not extra code. That's the key point.
So let's see, so full visibility. So this one's an interesting one, right? So if we look at the industry again, the various different solutions that are out there, you'll find a lot of times you have to figure out, was that piece of information available via SNMP? Was it available via some other programmable interface? Or was it only available in the CLI? We have a choke point. The in-memory database represents everything. We have an automated REST API generation that ensures that's all exposed. So there is nothing that's hidden underneath those covers. Again, full programmability becomes a side effect of that philosophy, right? Because everything was expressed in the database, because everything is required to be expressed in the database, because we can auto-generate the REST APIs on top of it, everything is programmable from day one. High availability, and Tom touched on this a little bit, and we'll get into it a little bit more on the next slide. The restart of a daemon, the daemon doesn't know if it was on the active management module or the standby management module. It's just restarting and reading its state from the database. So it's not two different sets of code, two different code paths that have to be executed depending on if I just suffered a failover event or if I had a daemon crash locally within the currently active management module.
I've got a quick question for you
Sure.
in the resiliency, because one of the hardest things in chassis architecture is maintaining the state of the rib versus the state of the fib and pushing those routes down into hardware. And oftentimes you'll see that's where the cracks come out, is you'll have a route in the rib and it's not in the fib and you're black holing traffic. So how did you guys tackle and approach that problem?
The synchronization ensuring that the
rib matches the fib and don't have a stray route somewhere that you're don't have hardware forwarding for.
So basically the generalized concept is a mark and sweep, right? When you have an event of a failover nature like that, you have to go back through and mark between rib and fib which routes are in common, and then go back through and see which routes are in difference so that you can resolve mismatches of that nature.
So there
and
is
you have
a
to do this in
consistency
multiple
check
layers.
that you're doing to ensure that you maintain
Correct.
the rib and fib inconsistency.
Well, and how often is that consistency check made? Is it when something comes up or goes down, or is there a random polling point, et cetera?
Failover events, right, or any event that would require it. So if you're routing protocol daemons restart, that would
The standard
cause
number
it.
of times where it's normally going to go and do
Yeah.
a recheck and revalidation. Okay.
So high availability. So almost all of the logic in the system is only running on the active management module. The standby management module is not an active participant in determining the state of the network, as it were. The agents, daemons, protocols, they don't know if they're on the active or the standby, right? It's the same from their perspective. They're just running. Actually, it doesn't matter where they are. In theory, they could be running somewhere else. As a practical application, we've chosen to keep them all in the active MM so that we have controlled domains. The state synchronization is done on a continuous basis. So every time there's an update to the in-memory database, that is replayed over to the current state database on the standby module. So it always has a current representation of the state of the system.
You said replayed, so that means it's transactional. What happens on the standby as well?
Yeah. Well, it's not transactional in the sense that the active will continue to move. It won't wait for the standby to acknowledge back and say I'm advancing at the same exact position. Right?
Okay.
So when you do have a failover event, like I mentioned before, you have a resolution phase where you make sure that your hardware state is consistent with the express state that the database has.
Okay.
Okay, so on the standby MM, there are a couple of things that do have to happen to ensure that we can quickly take over in the event of a failover. So not everything is completely passive. And what this really boils down to is the Linux kernel needs to be ready to be able to forward traffic for us in the event of a failover, right? And the Linux kernel can't do that if it doesn't know what the route table looks like, what the ARP and ND situation looks like for the neighbors. So at the point of failover, the Linux kernel already knows what interfaces are active, how they're functioning, what neighbors we need to talk to, and what the routing table looks like. Hence, as soon as that failover event occurs, my OSPF instance restarts, just as if it had started on the active. It can start sending packets to a neighbor without having to wait for the kernel to do any resolution. More important with BGP, where you have multi-hop, your next hop peer isn't necessarily on the same network, but OSPF also takes advantage of the same solution. Our theme, full programmability. So I've already mentioned it, but everything in the database has a REST API created for it. Right? This is an automated process. Every time we do a build, we get a brand new REST API. It's available and exposed for the customer and for engineering to use to continue to build and develop new tools. One of the important points here, everything is programmable from day one, right? So if you want to do a full network management application, you can do it. If you have software-defined networking visions you want to do, we have a platform that can enable you to do that from day one. It's also appropriate for cloud management solutions. So you can start to develop now, if you wanted to manage your network through a cloud deployed solution, the REST interface is exposed and available and can be used in a secure manner to support that solution as well.
When you say secure manner, can you clarify?
The certificate SSL.
Perfect.
Right.
Okay, thank you.
Yeah, so we didn't spend too much time on it. We touched on it in the hardware section, the fact that there's multiple TPMs. So go a little bit of detail on what we mean there when we say that. So the system actually has a TPM on the MM and a TPM on the RDC. Right, so that rear display card, as Mike refers to it, and is probably an easier way for people to understand what we're talking about. There's a TPM there that actually identifies the chassis, right? And so it has a secure certificate that identifies the chassis and protects the chassis' identity so that you know that this is really the chassis that you want and can validate and has a signed private key certificate to validate it. The MM has a TPM on it, which is where you actually get your secure root of trust from, right? So this, when you actually start booting, the BIOS will actually be validated. We will store the signature key into the TPM. Our bootloader also is validated and signed value stored in the TPM. And then the product code, as it is loaded by our bootloader, also goes through that process. So secure root of trust all the way from initial startup of the system to the product OS running. And then with those TPMs, now we also are loading certificates that can be used to secure your TLS, SSL applications on the user side as well.
Okay, so I just want to make sure I got it clear. There's a TPM that identifies the chassis itself, and then there's another TPM on the MM. And what does that do?
The TPM on the MM is about the secure root of trust for the software that's loaded on the device.
Okay.
The TPM on the chassis is about the secure identity of that chassis itself.
Okay.
Right, so it's two divided domains, and that allows for the management modules can be moved from chassis to chassis, and they can get the identity of the chassis because the chassis identity is stored there on that TPM on the rear display card.
So on the previous slide, how fast is the refresh of the database between active and standby for new state changes?
It's a 10 gig link there, and the application that's running for that synchronization is embedded within the database, so it's near instantaneous, your sub-millisecond levels.
Cool.
Obviously, size of the update has a factor on that as well.
On the secure boot process, someone could be thinking, well, that sounds terrible because if something doesn't check out, maybe it's all legit, but I can't get my switch up and running. How do you respond to that?
So there's a recovery mechanism, even in worst case scenario where all of your signature fails, we can dump you to a serial console that will allow for a recovery mechanism, right? And still get back to your secure root of trust from there.
Meaning you got to rebuild the trust chain
Yeah.
along those lines, but you can. So you've got some access to the console. So you still could be, you can't just say, well, I know it's not secure, but boot it anyway. I got to get packets forwarding.
Can't do that.
Yeah, okay.
Yeah. We don't want to, it's not a brick, right? We don't want it to get to the state where it's a brick, so it needs to be recoverable. But we won't boot if we don't have a valid OS image that we can sign and validate is ours. We won't continue in the boot process.
Okay.
But still have a recovery mechanism. There. Full visibility and monitoring. So again, we're coming back to this point, programmability. Why does he keep talking about programmability? Why does he keep talking about full visibility? Well, this is the basis on which we can create some really unique differentiation in the marketplace and in the capabilities that we can provide to our customers. So it's this programmability that allows us to now add a time series database that can be used to monitor the progression and changes in any value that's exposed in the database. And we already know, because I keep saying it, everything's in the database. So we can now create things that can monitor and monitor changes in a given state over time. So if you were worried about, say, if any given BGP peer goes away twice in 10 minutes, I want a notification. It's trivial to implement a script that can be able to do that using that time series database and the fact that your peer connection state is available within the database. So that's a key fundamental value add that making everything programmable and following our strict philosophy has enabled us to achieve. Now, again, since everything is there in the database, anything can have the application of the time series database that can be used then to create richness. BGP is the simple example that I like to use. One of the most simplistic and interesting ones that I've seen done is the simple fact that CPU utilization is there as well, right? If my CPU utilization exceeds 90% for 5 minutes, something you typically do with a remote device trying to monitor the state of the system itself can monitor. And if it identifies that situation, it can collect information about itself. In the next presentation, they'll go into some details about what that looks like, what types of things can be collected, and how that can be applied to not just my physical instance of the device, but other devices as well. So now we get a little geeky. So the fundamental aspect of a core switch router, any device in this class, is make the fast path work fast, right? Get things programmed down into the ASIC and make sure that the ASIC can handle all of the packet forwarding that the data plane needs as quickly as possible. But in order for that to work, that means that the management plane and control plane have to be able to get packets in and out of the system as well. So since we built and layered this solution directly on top of Linux, we wanted to follow the very Linux-like mechanisms. And so what that means is, for every interface, there is a standard Ethernet or a virtual Ethernet interface within the Linux kernel. So any application that we're write can use a standard Linux kernel, or excuse me, standard Linux socket to communicate with the network, connect, and get the interactions that it needs. In order to protect the control plane, we have control plane policing policies that we can apply across the board based on protocol, based on ARP, whatever it needs to be to ensure that the critical protocols are making it in, and in the event that somebody's trying to attack or corrupt your control plane, we can filter out that noise and get that dropped on the floor. All of this, again, is just to support the ability of us to get things programmed down and pushed into the ASIC so that the fast path can take care of all of your data plane forwarding. Now, there are still events in the world that require the slow path to get engaged and actually do forwarding. And again, we're using Linux natively. Linux routing is going to do our forwarding for us if we have to use the slow path, but we do everything we can to make sure that that's minimized to the extent that is humanly possible with the solutions as they stand today. So just details, since they're up here on the slide, and I'll at least speak to it. The actual presentation of what a port looks like is very standard. So if you're talking about port 1/1/1 on the front plane, the Linux kernel version of that Ethernet, virtual Ethernet device is 1M, 1S, 1P, and that's basically our M1, S1, 1P1, right? So that's member, slot, port, right? So regardless of where you're at in the box, it's a direct mapping, very easy to know and get that right connection for your Ethernet device. For VLAN support, we're using standard Linux VLAN support. Again, don't reinvent the wheel. Take advantage of the solution that's there. Make sure that if anything changes in the Linux kernel that we want to take advantage of, we can migrate kernels without massive amounts of pain. There's a lot going on in the Linux community space right now in regards to network, a lot of things that we are very interested in and want to be able to take advantage of. If we were making our own modifications, that would be a very complicated task for us in the future.
You support NetFlow on this new OS?
We do not have NetFlow support as of today.
So this is your own ASIC driver?
Yes.
As opposed to SI or?
Yeah, so no, we're not using a SI or one of the many attempts at a standardized abstracted interface for ASICs. In my experience and exposure within the industry, you can do a lot of the basic stuff really well with standardized APIs, but when you have interesting and unique capabilities exposed by an ASIC, they don't necessarily apply themselves for really taking advantage of that. We do have SFlow support, right, so good point. We don't support NetFlow, we do support SFlow.
I figured you support SFlow, yeah. I didn't think that was, I didn't have to ask that.
So ASIC programming. So you touched on it, ASIC driver. So the actual programming of the ASIC itself is actually done by a line card CPU. And we do this for explicit reasons. That line card CPU gives us a very controlled view of the state of that ASIC. And that software instance on that line card knows the state of that line card at any given point in time. So in the event of actually incurring a failover event, we always know exactly what the state of the hardware on any given line card is and can get that situation resolved and synchronized back to in sync with what the database says it should be. The database is always the single point of truth. So whether it's the active MM or the standby MM that's newly becoming the active MM, that database representation of what the desired state is what the system gets itself to. So at a failover event, these line card CPUs and their state will get updated to reflect the exact state that's expressed by the database. Right.
So we've got a three-part question.
Okay.
Yeah, I think that might have answered part of it, though, right? Are you talking about the same one?
Well, there's Brad's, and then there's Jay's also question is how many Linux virtual ports can we have for one physical port, which also feeds into the other ones there.
Yeah.
So yeah, how many virtual ports can we have per physical port?
So right now it's just one.
Just one?
You can do splits in the future, but that's right now it's a single per.
And you want to take this?
Yeah, the other question is how many ports per ASIC? And then what are your failure detection capabilities for bad ASICs on a card?
Okay, so multiple questions there. So
Yeah.
ports per ASIC, right now it's 32 ports per ASIC, right? So the speeds and feeds that we have on the device, it's 32 by 10, 8 by 40, or 6 by 100, depending on which line card you choose. The second part of that question, I just drew a blank on.
What are your failure detection
Failure
capabilities?
detections, thank you.
Yeah.
So there's multiple things. As Mike mentioned in the previous section, there's multiple databases within the ASIC. Each of those databases potentially has its own unique mechanism, be it an ECC or a parity error recovery, right? Those events are detected, caught, and then the table is updated to reflect whatever corruption might have occurred. In a worst case scenario where you can't get the ASIC table back to where it needs to be, then you would have to flush and restart, but that's expected to be the off case because now you're talking multiple layers of corruption having to occur to get you there.
Gotcha.
So talking of layers of corruption, how much, so this is underlying Linux and the ports are mapped into Linux as M1, S1, P1 and so on. That's great. How much do we, as a user, can we fiddle within that Linux? So can I start getting into the shell and injecting packets into ports and having fun? Or is it more protected than that from people who would do evil things?
So if you own the device, you're not doing evil things. You're just doing what you want to do.
Never, no.
So you can absolutely get into the Linux bash shell and you can start poking around and interacting with those devices. We do have a disclaimer, right? Once you're going into the shell, you can get access to lots of things and you can do lots of things that we may not necessarily be able to protect you from.
Sure.
So we can't protect you from yourself. But other than that, absolutely, you can go in there, you can start doing TCP dump directly on those ports, start collecting information about what's going on, seeing packets come in directly on your device. Obviously, that's something you should be careful of. You don't want to oversubscribe your control plane because you're doing a TCP dump on the front panel. But
Right, and I was going to go into that, but wasn't sure if that was something you'd cover later, would be packet captures and so on, because
right,
it seems like with that kind of throughput, that would swamp the CPU very quickly.
Yeah, you wouldn't necessarily want to take that approach if you could avoid it, right? You can, so we do support several solutions, right? So we can do a remote tunnel sniff, so you can apply an ACL, have the action be mirror this, right? Send it out a tunneled interface off somewhere else. That's really the preferred mechanism if you want to really do that type of analysis. I think for the future, we'll absolutely add that capabilities to be able to apply an ACL for filtering of what you want to receive onto the CPU control plane directly on the device.
Exactly what I was hoping.
COP will protect you to some extent, or excuse me, I said COP, and control plane policing will protect you to some extent if you start running a TCP dump on a given port, but you still want to be careful there.
How much CPU and memory is in there?
The CPU is I lived this for years and I can't, it's drawing a blank on me. So it's an Intel embedded SoC Xeon class device, 4 cores running 2.0 gigahertz per second. Memory is 32 gigabytes on each of the MMs.
And then is there any onboard storage?
There is onboard storage. We have a 120 gig SSD. And that is obviously shared between software images, the time series database collection, and configuration information as well.
But if I want to do something like write a TCP dump to it, would I have access to that? I saw you wince.
Yeah, I don't know that I would recommend that, but it's
You would not
something
recommend
you
it,
can
in
do.
fact.
Yes. Yeah. There's a certain reliability you want to achieve, right? We didn't design this box for not being sustainable for greater than 10 years. If you're going to go and start using your local SSD as a TCP dump storage ground, you're going to wear out that device much faster than what our projections would.
Oh, not
allow
right. Not
for.
even a space issue necessarily. Just reads and writes and so on. Yeah.
Yeah.
So going back to the control plane, I've just got a question when he was talking about the CPU. As far as the routing stack and other protocols, are those multi-core on as far as your routing stack, or are those single core?
The routing stack is a single core implementation, so it was just beyond one, but and that's why we specifically chose the particular CPU we did. We were looking for single core performance, very strong.
Yeah, that makes a lot of
scale.
sense.
Yeah. Right, but you're not sharing, the routing, basically the routing daemon can completely monopolize one core, the rest of the system will use the other three.
Gotcha.
And it's also hyper-thread aware, right? So it's 8 threads, 4 cores.
And the 32, we're talking like, is it 2 16s, 4 8s, 132?
2 16s. Mike is the hardware guy, but I don't know. It's 2 16s on the memory, right? Yes, yeah. I was pretty sure hardware guy is always a better validation.
And you've probably got enough cooling to be able to overclock the CPU if you really want.
Change the memory out.
Take the fans.
I believe you said you bought it, you can do whatever you want with it. Those were the words.
Those fans could probably hover your desk if you really wanted to put it under your desk.
So it doubles as a quadcopter. It's like it'd be a drone. Yeah.
Except it's an 18 copter, so I'm not sure what that word would be.
Octadecagon.
No, thank you.
Sounds like a lab
Octadecagon.
exercise
You
for
learn
you.
something new all the time. There you go. Let's see. So go spend a little bit of time, talk a little bit about user interface experience here with Aruba-OS-CX, right? So this is new, so what's that mean, right? So we all know and love the CLI. It's been what networking engineers have been using for 25, 30 years. It's not exactly the sexiest thing, but it gets by, people can do their day-to-day jobs. So we needed to make sure that we had a CLI that we could bring to bear, and in order to do that, we wanted to make sure that we could bring people along that have experience in the industry and even people that aren't as deep knowledge on what the capabilities of a CLI are and get them where they need to be. So to do that, we had to have a philosophy. What are we trying to achieve? So we wanted to make it intuitive. We want to keep the depth of commands short as possible. If you need to configure something, you shouldn't have to go 6, 7, 8 layers deep in the configuration options in order to figure out what you need and get that updated. So you want to keep it short and concise. Now, the short and concise doesn't give the full richness and power to the engineer, network engineer that's been doing this for 20 years. So you do have that deep richness if you need it, but we want to make it so that the average engineer, the 80%, can be successful without having a huge learning curve on getting into the device. Like blurred all 3 lines together into a single sentence there. So simple, same rule of thumb, right? You shouldn't have to try and interpret or be confused by the command set that you're seeing. Short, like I said, don't want a deep 17-layer deep command set. In order to enable something, you should be able to do it in 2 or 3 commands. We're trying to follow that line. And consistent. Don't have different meanings for different verbs within the system, right? Don't have things that are going to make it very easy for somebody to get confused because no means something in this context and something different in that context. Make it consistent across the board.
And it builds on past CLI nomenclature and terms that we're all used to from any other types of platforms.
Right. So several other platforms, if you've come from one, you can get familiar with this interface very quickly, very easily. You're not reinventing the wheel. Everything seems very familiar.
Is this CLI an API consumer? Did you say that?
It does not consume the REST API directly. It has a direct connection to the in-memory database.
Okay.
But everything goes to the in-memory database. That remains a consistent rule as things go forward. So web UI. So we'll give a demo of the web UI in the future session and go into this in more detail, but just as a flash kind of a sense, right? There's 3 separate basic UIs that are exposed for the device. Web UI is one of them. So it's a modern designed web UI with widgets that can be adjusted. You can change your dashboard to fit your needs, whatever's important to you when you log into that device. That's what you can have be the predominant feature of the dashboard. The analytics engine is represented in the dashboard here, and you can actually customize that to really display the things that are important to you. And again, in the next presentation, we'll go into much more detail on that, the analytics engine, its capabilities, and how you can actually integrate all this to make your network administration life easier. So Swagger interface, and I'll demo this. I'll demo this after a little break, and we'll kind of go through it and get a little look at what's here. So we've talked about it, REST API, everything's programmable. Well, here it is. It's all documented. There's a Swagger interface directly on the device available through the web interface. You can go into and you can drill down into the detail of any of the given tables, what the columns within that table are, valid values for those tables, and you can use that Swagger interface to do updates and configuration on the device.
This is HTML5 or not Flash or Java based? Just to be clear.
It's, yes, not Flash or Java based.
You open Pandora's box.
Yeah, you're not updating your JVM in order to make sure it still works. And any other questions there?
Not there.
Telnet SSH standard.
Yes, Telnet. No Telnet, actually.
I'm actually glad
only.
to hear no Telnet.
Yes.
No, is that web UI? I know you're probably going to get to this later, but I'm just curious. Is that web UI also the basis for the analytics that are built into the box? Same single pane?
For the interface, from an interface perspective, yes. That's that's where you interface with it. That's how you find information about what the analytics engine is doing, and information along those
And
lines.
to that point, and again, we'll probably cover it later, is the analytics engine running on box all of its capabilities, or do you spawn off a virtual machine that you load into the environment in some capacity?
It is an LXC container, libvirt container, right? So lightweight, isolated, so we actually have some CPU control. Again, I want to protect my data plane or my control plane and make sure that your network stays functional, even if you do want to go and write an analytics script. I don't want that script to be able to bring down the control plane and suddenly OSPF goes down because you have an analytics engine running, right? No. It's contained off into a container where we can control its memory utilization and CPU utilization.
Is there, whether configuration or operational, is there anything that's not available via CLI or web UI versus REST? In other words, are they equal UIs, or is the one that gives you everything and the web's like 80% daily stuff? You know what I mean?
Web is more based, the web interface, because the web interface is a developed thing to expose it. It's using REST on the back end, right? So REST has access to everything,
right.
But the web UI only has whatever we build web interfaces to actually support, right? So the web interface does not have everything, but the REST that's backing it up absolutely has everything.
So from a configuration standpoint, because I understand there's an awful lot you could potentially monitor, but from a configuration standpoint, is there anything that I would have to go to CLI to configure because I can't do it in the web? Are there gaps there too?
Yeah, absolutely. From the web interface is not meant to be a whole system, every bell and whistle management interface.
Okay.
Right. You can, what's backing it up is REST, so it could be extended to get there, right? But the CLI, if you're getting deep into the BGP feature set, the CLI is your friend.
Right. That makes sense.
But again, you can do all that via REST as well. So real quick, and one of the things that we haven't talked about, but part of the philosophy being in-memory database centric and everything being expressed in the database is the configuration is declarative. That means if you wanted to take and send a brand new JSON blob that represented the entire configuration of the device into the device will get itself to that state. So there's a few things that come out of that and that philosophy extends to enable. And one of them is this concept of automatic configuration checkpoints. So by default, if you're doing configuration on the device and you've left it in a dirty state, haven't done a save, it will automatically take a checkpoint after a 5-minute time. So what starts happening now is you start getting checkpoints of the configuration as it's changed over time. And you can actually, at any given point, say, oops, I messed up. Go back to checkpoint from 5 minutes ago. And the system will automatically go back to that point, no reboot required, and get you back to where you were. Now, this gets extended to the point where you can actually do an automatic rollback based on a timeout. So if you're a remote network administrator trying to configure the box and you're coming in over a WAN link and you accidentally write an ACL that locks you out, well, if you'd set the automatic recovery point, when your timeout expires, it'll roll back. Your WAN access will come back in line. You can come back now and get back to configuring the box where you left off and hopefully get your ACL right this time.
Saying declarative, so that means this would be diff-based. So if there's one thing different, it's going to change the one thing to get you to that
Correct.
state. Yeah.
Right, and that each of the checkpoints is stored as a diff.
Yeah.
And is there a way, the checkpointing is available and invisible from the command line? That's question one.
Correct.
And you can, from the command line, say, I'd like to diff these two checkpoints and show me the difference, as opposed to having to, let me show that one, let me show this one, let me go copy it into Notepad, and let me do a comparison. Just because we've all done that a billion times, and that's how we do things because we don't have a systemic way of doing it.
Each checkpoint itself is a diff. Will it diff any 2 points in history?
Absolutely. Yeah, so when you look at the diff definitely on the web UI, what you see is a diff.
Yeah.
So show you the differences between these two checkpoints I have. So if I want to pull up a checkpoint from a month ago, and there have been 1,000 changes between then, but I also want to see how it compares to today.
Well, it's 32. It's 32 checkpoints deep.
So there was 30 changes between now and then. So I'm doing dailies or whatever. But I can go and look at any point in time to compare it to the current point in time.
I can't remember what we have right now. That's easy to extend to.
Okay, thank you.
One question on that, because this is something that you don't run into very often, but it does happen when you're doing some kind of a configuration rollback. You'll hit a caveat. It'll say, oh, I can't execute this because of this. Is there any allowance for that? Is there any problem or issue with that you guys have run into? Where I've dealt with it in other vendors where you'll do a rollback and you'll get an exception and it says, I can't do this because of whatever. Is that even an issue for you guys?
I haven't hit any of those cases. I'm trying to envision what the scenario would be that you might short of.
Lag was one I hit just actually last week. I was trying to do a rollback on something, and because the ports were in a lag, now I don't know why, I don't know if it was a bug or what, but it just said these are in a lag, I can't roll back.
The reason you'll hit that in other systems is because the business logic for the application and the state it wants to be in is contained within the application, so it can advance to a state, and it doesn't understand the directive being given by the config subsystem. Because of the way this thing's architected, where the state database is the single source of truth, all applications are required to be able to synchronize to that state. So it's a violation of the architecture to have the corner case that you talked about.
Okay. Exactly. The declarative nature, right? So every daemon has to be written to be declarative to, if I get a newly expressed state, I have to get to that state. Okay. So I don't get to have a caveat of, oops, right? So
the only whoops would be like someone ripped a line card out, right? And so the line card's gone. It can't be programmed. You're going to see, oh, hey, that thing's gone now.
Yeah, and that's fair.
So these checkpoints, are they synchronized between the MMs?
Yes, they should be synchronized. Yes, absolutely. Yeah. There's a file system sync in place for all of your configurations you do that syncs continuously. Other questions there? All right, so that wraps it up for the Aruba-OS-CX presentation as it were canned so far. I do want to address a few comments that were made from the hardware session. So on the IPv6 front, right? So modern Linux, dual stack from the start, ARP, ND obviously, OSPF v3 support as well. So we have a rich IPv6 feature set as a base and still extending. The ASIC and hardware architecture is built for IPv6 from the ground up. Those database tables, some of them will share and be split to do IPv4 versus IPv6. You have IPv4, IPv6 unicast, IPv6 multicast tables. So it's all just a matter of how you share and distribute those resources depending on your deployment scenario.
You did start off by talking about spanning tree slightly. Are there spanning tree limits? You mentioned it, right? And I actually wanted to know, do you have any hard limits actually set in the system?
In terms of,
The maximum number of spanning trees is established.
so 802.1s, near and dear to my heart, 64 because that's the standard length and the standard number that can fit within a BPDU. If you're doing per VLAN, maxes out at 256.
And that's a hard limit max.
That's a
as
hard
opposed to-
limit.
because you could remove that. It's just the code line because we had those limits in the past because we had memory and CPU problems.
Yeah,
These days, well, it's not really
Yeah.
too much of an issue anymore.
Yeah, personal opinion, as much as I love spanning tree, I would
much
not
as I
want to
hate
run
spanning
256 trees.
I was just say I've had the need to expand beyond that, and certain vendors in their chassis had no limit, which caused nothing but heartaches during migrations because there was no limit implied.
Yeah, and you end up way over what you
And
can
then
actually
having
do
to
in terms of
re-architect spanning
generating
trees,
packets.
support the environment, and remove VLANs. Yes.
It works great so long as nothing ever changes.
That was a 2-year migration, so.
Well, and because you opened the door, are you exploring other loop prevention protocols in the future to move away from spanning trees?
So MC-lag as a basic infrastructure right component that we're doing is one of your mechanisms for avoiding loops. We're certainly paying attention to all the things that are out there. There's a lot of interesting developments in that space, especially as you start looking at what you can potentially do with overlays. So there's a lot that we're considering, but I won't go into the details of the directions that we're looking there.
Sure.